Good morning, good afternoon, good evening, folks. Thanks for joining us today. We're going to get started in about 2 or 3 minutes here. We've got a really cool topic around antennas, Wi-Fi antennas today. Mike Graham joined us today, and really exciting stuff. Since we've got some time beforehand, thank you guys for dialing in earlier. There's a significant amount of you guys dialing in, guys and girls dialing in early today. If you could let us know where you're dialing in from, that would be awesome. I am at the headquarters today. I think I've got 4 consecutive weeks here at HQ on Wednesdays. And Mike, where are you joining us from today? I forgot to ask you this morning.
I'm in my home office in Charlotte.
In Charlotte. I always forget that's where you are. Let's see what we've got coming in. We've got Paul in Southeastern PA. Welcome back. Chris, welcome back from Texas. We've got Alan. Good morning from Santa Barbara. Awesome. Yes, good morning is right. I know it's a little early there for you guys. Abu coming in from South Africa. Welcome. Jim is in Oxford. Thanks for letting me know, gang. We've got Stockholm, Sweden from Dan. And now I got to throw my specs on. We've got North Carolina from Michael. Welcome back. Alan is in the public defender's office. I hope that's a good thing. Either you're an attorney or or something else is going on. Thanks for the heads up. Let's see. Home office from Daniel in Zurich. Awesome. Boston, Peter. Chris is in London. Oh, Luton Airport. Welcome. Thanks for coming today. All right. I've got 11 o'clock on the nose. You guys could keep those coming if you're comfortable doing that. Again, letting us know where you're dialing in from, whether you're working from your home office or in the office today. So I've got 11 o'clock on the nose here on the East Coast and in Ohio. We'll go ahead and get started. Thanks for joining us, folks. We've got a great topic around antenna concept. It's a continuation of a webinar that Mike and I did, mostly Mike. We did about maybe 5 weeks ago now, 10 huge antenna Wi-Fi mistakes. Mike is going to walk us through that. He's going to introduce himself in just a few minutes here. I've got a handful of slides that I wanted to run through, and I've got a polling question that I want to ask all of you guys about for an upcoming event and see if you plan on attending. So just as a reminder, these events are CWNP certified. So for those of you who are getting your CE credits toward a certification in the wireless world, you can use these as credits for that. You get 1 credit per webinar. We won't get into the product today, so if you're a newcomer and you're looking for a product tour, you can go to go.7signal.com/tour. We try and keep these webinars more around best practices and tips and tricks that you guys can use now to troubleshoot Wi-Fi. We will copy today's recording and put it on YouTube so you can access it there. And I've got a question here around the wireless technology forum for you guys before we get going too. So let me drop that in here. For those of you who are attending this in Vegas in September, I'm really curious, for those of you who are going, this polling question seemed relevant to me. It started to get a little bit of activity this week on Twitter. And I was just curious for those of you who are still attending, and really this dovetails into whether you're attending events at all. And I suspect the answer is no, but I just want to make sure here. So let's see, let me close this poll out and share the results. Yeah, it looks kind of what I thought. Some of you are on the fence. The majority of you are not attending. So and I don't have any more information on the event other than we had it on our radar to do, and they may end up doing a virtual event, but we'll get with our friends over at CWNP and get some more information around that. But thanks for indulging me in that. Real quick, we've got a promotion going on for those of you who are new to joining us. We are giving away Mobileye to help you with troubleshooting some of your remote employees and their devices on their home networks. I'll drop this link into the chat, but you can go to go.sevensignal.com/50 for 50 and get information on that promotion. Very simple, up and running in just a few days after an initial discovery call with us. So a little bit about Seven Signal. We've been around since 2007, and we've hit a lot of major milestones along the way. We now monitor over 1 billion data points on a daily basis. We're on a lot of networks, on a lot of devices, measuring a lot of KPIs. We're homologated in over 40 countries around the world. We're GDPR compliant. So for those of you in the EU and UK, that will resonate well with you. So not only do we stay up to date with our technology stack, but we're also staying up to date with all the privacy standards that are out there, and privacy is paramount for us. We've got over 200 customers around the world, many global organizations. We've got 14 patents. So when you do look at one of our products, you'll know that you're only going to see those capabilities from Seven Signal because of those patents. We're here because we think that the digital experience matters, and is extremely dependent on Wi-Fi. So what we've done over the last 15 or so years is created a completely AP and device agnostic framework that is outside in, and I'll get more around that in a second. But Mobileye and Sapphire are our product names. And what we're doing, since we focus on Wi-Fi, we're focusing on what we call the top 7 Wi-Fi problems. So these problems present themselves differently, especially to the end user. The end user just knows, hey, I can't connect, or my Wi-Fi is slow. They never call you and say, hey, the Wi-Fi is awesome today. But the root cause is one of these 7 issues, whether it's congestion or coverage or interference or roaming. What we do with our software is we get right to the root cause of those issues. Because we're outside in, we can get that access better than anybody. And what we're doing is we're running active and passive tests either on the device or on the network, depending on the solution that you have from us. Checking things like throughput, packet loss, latency, and jitter, looking at adapter driver combinations, getting you a full spectrum analysis with packet capture. And if you look at it from a standard enterprise LAN infrastructure, a lot of folks on the call who aren't Seven Signal customers have what we refer to as the inside out approach from their vendor tools. And there's great information that those vendors are pulling. SolarWinds, AppNeta, and others that are pulling that information about application performance, about network performance, but they're limited in what they can see. So Seven Signal is here to complement them. So Mobileye is an agent that lives on the devices, that's looking at the user experience and their Wi-Fi service level quality from the agent's perspective, something that you can't get from that inside out approach. And the same goes for our Sapphire Eye. The Sapphire Eye is a perfect client or sensor that lives up in the rafters with the access points, that's looking for service level quality, RF visibility, things like that, and some network services as well. But we're not going to get into too much product stuff today. That's not what today is all about. But just a side-by-side comparison, Mobileye on the left, Sapphire Eye on the right. Mobileye, again, is the agent that lives on the device, so your scanners, your other handhelds, your workstations on wheels in hospitals or manufacturing areas, your laptops on VIP devices. Looking for things like adapter driver combination, roaming issues, adjacent and co-channel interference. And then on the right, our Sapphire Eye is our software-enabled hardware that lives up in the rafters with the access points, looking at things like network services, wireless LAN configuration, giving you a full spectrum analysis with packet capture. So 2 different solutions covering 2 different problems. Together, they cover all 7 Wi-Fi problems because one has agent access and one does not, or endpoint access and one does not. There is a definite advantage gained there. Both products report up into the cloud and are accessed via software as a service dashboard. And both products are also priced on a subscription basis. So we're not going to get to Q&A yet, but I'm going to hand the controls over to Mike, and we're going to get going. And while he's pulling up his dashboard, or excuse me, his PowerPoint slides, I'm going to throw up another trivia question and try and get some audience information here. So a little trivia question, maybe set the stage a little bit and see how knowledgeable you all are with antennas. So we've got this question here is, of the following antenna connector types, which one is the smallest? So I'm going to let that hang up here for just a minute and see how you all do. And Mike and I can see the results as they come in. Mike, and it looks like we've got a smart audience around antennas today.
Good.
All right, let me close this poll out, see how you all did. So B is the correct answer, MC connector. So 42% of you guys and girls did well. Mike, I don't know if you want to add any color around this, but there are the numbers.
Yep.
Yeah, yes, they are. Yes, those are numbers. All right, so let me hide these results. Mike, the floor is yours. You should be able to share and lead us into the next level of this presentation.
All right. You see my screen?
I can.
All right. Just first a couple words about me. I'm a SE at 7 Signal, and I think if I've counted right, this summer will be my 6th year here. So kind of an old timer for 7 Signal. And I have been designing, installing, troubleshooting wireless LANs in some capacity since the early 90s, since before Wi-Fi or 802.11 was a thing. Started out with, I said 450 megahertz LAN mobile band wireless LANs, and moved on through 900 and 2.4 frequency hoppers and on into the Wi-Fi world. So I've been doing this a while and seen a lot. Don asked me to do a little bit of a presentation around a document that's been on our website for a while, 10 huge mistakes with antenna installation. So I went back and took a look at that document and kind of have my own take on it. So let's go ahead with that. I went through there and kind of came up with 3 really basic principles for omnidirectional antennas. And I want to make clear here that this whole discussion is around omnidirectional antennas, either the integrated antennas and access points or rubber duck dipole type antennas or big stick collinears. We're not talking about directional antennas here. But, those 3 principles that omnidirectional antennas really perform best in free space. They like room around them. And we'll cover a little bit of why on that, but remember, they like their space. They also are going to perform best in the center or near the center of their intended coverage area. I mean, I think, kind of obviously, if your coverage is in all directions, you want to be not on the edge of your coverage area. And the third one, which is a principle not only for omnidirectional antennas, but antennas and access points in general, is put the signal where the clients are. Think about, where that antenna is going to be radiating its signal and where your clients are going to be using it, and put those in the same place. So I went through those 10 slides and really came up with a handful of sort of bad things that happen, and none of this is super precise. I'm going to say 5 inches or 13 centimeters, and really, I'm talking about very close to the antenna, and these are approximate rule of thumb kind of measurements. But we say that the antennas like free space, and if you get something, an object, within about 5 inches for 2.4, 3 inches for 5 gigahertz. That's inside of about a wavelength. And those objects will affect the tuning of the antenna. That's a characteristic of antennas is they'll behave differently when they're surrounded by free space, air, or the plastic sheath on them slightly affects the tuning, and of course the manufacturers take that into account. And then if you place objects near them, that will affect the tuning as well. So when the antenna becomes detuned, it's not coupling the energy from the transmitter efficiently to the air, or vice versa. It's not coupling the received energy efficiently to the receiver. So you want those antennas to stay in the manufacturer designed tune. The second one is objects within, say, a couple of feet or foot or foot and a half or 5 gigahertz really makes a big difference in the pattern of the antenna. It's no longer going to be an omnidirectional antenna. Particularly, we're talking about metallic objects, but really anything is going to affect that pattern. And that's what a panel type antenna is they take usually a dipole and they put it a very specific distance from a reflector and dial in the exact pattern that they want. And when you're mounting an antenna close to a wall, particularly in metal buildings and that sort of thing, it will change the pattern, and it's going to change it unpredictably since you're not likely doing those very careful measurements and calculations. The third thing, and this speaks to the, wants to be in the center of its coverage area, is, you're wasting capabilities of the antenna, the access point, whenever you're covering areas that don't include client devices. So access points out near an outside wall or near thick walls or near the area, edge of your coverage area. Related to that, signal that isn't close to the client. So antennas up in the air, so all your signal is way above the working floor. And there's a lot of overlap between those two, but I was basing this off of the original document, and they kind of broke it out separately. Finally, or not finally, but also when you have access points that are covering each other better than they're covering their clients, they're all up in the roof, they're going to increase their self-interference. And that's somewhat an unavoidable situation. Even if you think about office environments, the area below about chest high has got filing cabinets and chairs and desks and computers and people in it. And in that area from head high up to the ceiling is usually largely open. And that's where the APs sit. So they can, they've got unobstructed views to each other, whereas they may have obstructed views down to things on the floor. And then finally, obstructions, just, not necessarily close to an antenna, but objects between the access point and the client, some piece of machinery, or, in a warehouse or commercial situation, it might be whatever product they're making, as it moves around, you have to consider, is that going to be in front of or between the access point and the client, and what difference is that going to make? So moving on to the review of the document. And the first big mistake we addressed was access point among pipes and ducts. And you can see our picture over on the right, up in the ceiling, and if you look carefully, somewhere in all of that tangle, there is an access point. And obviously, that access point is not going to have a clear line of sight to anything So we're going to get signal reflections. They're going to be bouncing off those pipes, those heating ducts, and certainly the pattern from that antenna is no longer going to be omnidirectional. It's going to spray signal off in some random direction. Next up is, whoops, what did I do?
I'm still seeing you.
Okay, sorry.
Yep. You're good. Yep.
Okay, no, I've just managed to block my view with the dock.
Oh.
Sorry. As I was saying, there's a signal reflection. That signal is going to bounce off of those ducts, off of those pipes. It's going to come out in some other way. Some of those ducts and pipes are going to obstruct what your intended path was. There's pretty clearly not a clear path between you and the access point, wherever it is. And finally, you're really inside of that few inch margin up there where you're going to detune the antenna. You're going to change that resonant frequency. So burying it up amongst the pipes is it's a pretty terrible thing to do, and we see it all the time. It's so easy to just take an access point and lay it up on top of one of those pipes or something, and that's just not a good thing to do. The other one, and I'm in hospitals a lot. They're a big customer of ours, and I see this all the time in hospitals. I don't know what it is, but they'll take an access point, they'll flip it around, and they will poke the holes through the tile and leave them poking down like that. I've even seen it through metal enclosures that were intended to have an antenna mounted on the outside, and they poke the holes through, or poke the antennas through metal. But you can see in this one, we're definitely inside that, 3 to 5 inch range that you want free space. And not only are we inside of that with the, fairly light, non-conductive ceiling tile material, we're up against the support rails as well. So that's definitely going to affect the tuning on those antennas. And I don't know if you can see, but on the upper right antenna, the tip of that one has actually been cut off. So it's definitely going to be out of tune in this one. The next one that we talked about was mounting an AP up against a surface. I see this a lot. It's an easy way to mount them. But one, you're up against an object within that 3 to 5 inch range, so you're going to affect the tuning of the antennas. And when you think those are omnidirectional, so they're going to be covering whatever's on the, or trying to cover whatever's on the other side of that wall, which is probably nothing. So that really violates the principle of keeping the antenna near the center of the area. Next up, and I've got a couple of these, real high ceiling buildings. You put the antennas up in the sky, up on the ceiling, and you think you're doing good because you can see them from a long way off. But those access points have some sideways gain. So they are projecting more of their signal out than they are down. And you can see they're lined up 1, 2, 3 along that raceway. So they're hearing each other really well. Their antennas are pointed at each other. So, we're not putting the signal down where the client is. We're wasting coverage up in the ceiling. And because the APs are hearing each other so well, we're increasing the chances that they're going to interfere with each other, that we're going to have more APs on the same channel that have clear lines of sight to each other. And then we have sort of the big brother of that, the same thing but worse. You've got an AP up in the ceiling, and you've got a couple of high gain collinear omnis on the side of it. So as I say, that's even worse. They're putting less signal down towards the ground, more signal out towards all the other APs up there. You know, it's just a worst case. And I know that, well, I've just said, well, you can't do high bay buildings with omnis, and that's not really the case. So I diverted here and put in a couple of other pictures. On the left, we have an access point hanging from a piece of conduit. They've taken electrical boxes and tapped-on them into the ceiling and dropped conduit to another electrical box and put the access point on that. You run the Cat5 through that conduit. It makes for a very clean install, and you can drop an access point 10 or 15 feet. You can get the coverage down where the clients are, and it's a clean, easy install, and it looks good. You might not be able to pull that off in a warehouse or really heavy industrial building, in which case you might look at moving to directional antennas located along sidewalls. And that's what we see on the right is about, it looks like every 20, maybe 30 feet, there are access points and a directional antenna, a little bit of down tilt on the antenna, covering sideways into their coverage area rather than trying to cover it from above. So both of those can really work well in high ceiling applications. The other one, or the next one here, is putting an access point near an outside wall or a thick wall or really the edge of a coverage area. You can see a little diagram here showing a small home or an apartment, a small office with access point off in the corner. You know, that's probably where the network line comes in. So they put a access point there, and you know, really only about a quarter of the coverage area of that omnidirectional antenna is even providing coverage into the office at all. The rest of it is, you know, it's warming up the walls and providing coverage outside. So, you know, real wasted coverage there. You move that to the center of the area, and you're going to get much better use of the access point. And I like this one. If you remember the previous antenna webinar, if you were here, we talked a little bit about one of the patterns of antennas with that are often built into access points is kind of what I call the blob. It really doesn't have very much gain. It's a coverage area right under, right in front of the access point. This isn't that. This actually has some gain. I don't know that you can see it on here, but if you go look at the gain numbers, the highest gain peaks on that, which, you know, in this implementation are pointing at the ceiling and the floor, are about 6 dB. Every 6 dB is a doubling of coverage. So, you know, it's a pretty good bit of gain for an integrated access point. But corresponding to that, you've got this big dimple in the middle, and that's about negative 6 dB. So there's a factor of 4 coverage difference between that dimple in the middle and those lobes pointing up and down. And you'll notice that we've got our guy trying to use his VoIP phone, and that is lined up just perfectly with that dimple. So he is standing right in the null of that antenna, and basically everybody in that room is going to be. There's just a head high failure of coverage here, lack of coverage, or weaker coverage. It used to be a much bigger deal before MIMO came along, because that signal shooting at the ceiling and the floor would be multipathing and self-interfering, and it would have been terrible. The newer MIMO radios, you know, it's still not ideal, but those reflections from the ceiling and the floor at least aren't going to be working against you anymore. So, you have to consider what the coverage pattern is for your access point, for your antenna. And obviously this access point would be much happier on the ceiling than on the wall.
And Mike, I'm going to hold you up there just 1 second. I am getting some notes from folks who are still having audio problems, and some folks can't see the slides. And I see people leaving and coming back in. I've been able to hear everything and see everything for the past 10 minutes or so. Everything seems to be going fine. But I apologize for the inconvenience, folks. We will make sure that that we pass out the recording of this because it is recorded from my machine. You should be able to see everything on the recording. So I apologize in advance for those of you who are having some issues. GoToWebinar has been really reliable for us for these webinars, so I apologize. Sorry, Mike.
No problem. Next up is painting the antenna. You see the question all the time, can I paint the antenna? And the answer is, as long as it's a non-metallic paint, generally you can paint the antenna. Using metallic paint, that's going to create a conductive shell around the antenna. It's definitely going to affect the tuning of the antenna. It may also act as an obstruction. There's a metallic shield between you and the radiated element inside. So it's really not an absolute no, but not a great idea to paint an antenna. And even non-metallic paints, the pigments in them, sometimes are conductive as well or reactive at radio frequencies. So if you are going to have to paint an antenna, and I have, check that it's a non-metallic paint and go as lightly as you can on it. I think we have one more or two more. And I've seen this before, really way too many times, is a radio, Wi-Fi radio, either an access point or a client in a metal enclosure, and it just doesn't work. You may get enough leakage so that it will sort of work, but it's never going to work well. So if you do have to put a radio, be it an access point or a client, in a metal enclosure, you do need to make sure you make a provision to bring an antenna onto the outside of that enclosure. And of course that, is both going to detune the antenna because it's, something within a few inches of the antenna, as well as obstruct it. You've got a piece of metal between the access point and the client, no matter what. And then finally, and I really see this as more of a site survey issue. And the issue that we're talking about here is that for VoIP devices, handheld VoIP devices, usually you're going to be holding them up to your head and you're going to be covering them with your hand. So you've got yourself obstructing that antenna on two sides. You might also think that it's going to detune it some, but that's been taken into account by the designers, like the plastic sheaths on antennas are taken into account. But really, I think the point on this one, since obviously that's the way you use the device, is it's a site survey issue more than an antenna issue, and that is that you need to test with the devices that you're going to use in the area. It's just a basic principle. If you're going to be using VoIP phones, you need to do at least some of the survey testing with that device, and not do everything with your laptop, which probably has a better antenna in it, and you're not holding it right up against your head. And that's the end of my slides, Don.
All right, awesome. Thanks, Mike. We lost a lot of folks here throughout. Some are still with us, so I think some are still able to hear and see. So again, I apologize for the technical issues here with GoToWebinar. Again, it's been really reliable for us over the last several months. So why don't I'm going to throw up a survey question here instead of going to Q&A, since although I'm going to ask the Q&A stuff here in just a second. There's a couple that came through. I don't know if the folks who asked are still on the line, but let me throw up a poll question before I lose the rest of you here. And it's around upcoming topics for webinars. So I want to make sure that we're always staying relevant and top of mind for you all. If you don't mind taking a second to let us know what topics most interest you around either more antenna topics or troubleshooting, design and planning, interference, or something else, please email me and let me know if there's something else. So let me close this poll here and see how we did. And it looks like it's kind of almost even. Design and planning, troubleshooting, antennas, interference, kind of all smattering. And I'm going to look for an email from some of you as well. So this will help us with planning moving forward. And I appreciate that feedback. So for those of you who can still see and hear, let me go in and see if I can pull out some questions. There's certainly been a lot of chatter around lost audio, so I have to go back to my little placeholders here. But one here for you, Mike. What is the best antenna for warehouses with 13 meters high and racks that sometimes are full and sometimes are empty? That might be a tough one to answer for you.
It is, and it's a tough situation to do. 13 meters, that's very high roof. Obviously, if you put the access points in the antennas with omnis up in the roof, you're going to have a real hard time getting the signal down to the ground where the clients are. So in those situations, I like to, if you can, attack it from the side. A lot of people will do alternating rows and shoot directional antennas up and down the rows and access points, or if it's a more open area, like the photograph we have where we had the APs just lined up against the wall, you can do that. If you have to be up in the ceiling, then instead of using omnidirectionals, you'll want to use a directional antenna, probably a really small low gain patch pointing down at the floor. So you're directing that energy towards the floor and not leaving it up in the ceiling.
Awesome, thanks, Mike. We're coming up on time here, and I know some folks are still messaging me about audio issues. So send us an email with your questions moving forward. We'll take them offline for those of you who can still hear us, and we'll shut it down for today. And I'll get a copy of this recording out to everyone immediately. And again, I apologize for the audio issues. Mike, you did a great job. I could hear you, and that'll convert into an audio from my machine, so that should all work on the recording side. So I appreciate your time, Mike, and everyone. Thanks for joining us today. We'll see you all next week.
Bye, everybody.